We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning friends, myself PATEL JIGNESH, Assistant Professor in Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we are discussing one of the topic from the subject of experimental technique and instrumentation in thermal engineering, in which we are taking the one of the chapter advancement in measurement. In this chapter we have to discuss about the controller. So basically we have 3 controllers: P controllers, PI controllers and PID controllers. So proportional controller we have to discuss today. So basically we start this lecture from this P controller. What is the P controller? It's defined that in proportional control system, the actuating signal is proportional to the error signals. And this one is my definitions for the P controller, in which they have to say that actuating signal is proportional to error signal. So now fundamentally what will happen in this controller is the one of the component which is the control the process. So basically we can go through the derivative, and then after we have to discuss about what is the block diagram of this controller and how it can be works, actually how process it can be controlled by the P controller. So go through some derivation. Before that, you can see in a definition in proposed controller system, the actuating signal is proportional to error signal. So fundamentally we have to know about what is the actuating signal and what is the error signal. So basically error signal, which is the difference between the reference input signal and the feedback signal. Reference input signal and difference between the reference input signal and feedback signal. So we can see some derivative over there. So the proportional controller produce an output which is the proportional to the error signal. So this one is my actuating signal and this one is my error signal. So ultimately, as per definition, we can see that your actuating signal which is the proportional to the error signal. Now we have to simplify that. We have to remove this proportionality by using of this proportional constant coefficient. We can see that proportional coefficient Kp ut is equal to Kp et. Now this one is in the time domain, so we can define in the form of t. It's a time domain. So now this one is we can taking the Laplace, so we can convert the time domain into the frequency domain. So we have to capitalize this one, U capital S is equal to Kp Es. Now we have to know about, we have to getting the value of Kp. Now this one is basically we have to create the transfer function. What is the need of transfer function? We have to draw the block diagram by using of transfer function. So ultimately we have to know about what is the output and what is the input. Now in the cases we have to know that actuating signal which is the US, and this one is my error signal. So if I producing some error, we are taking the one system over there. When we are applying some reference signals and we are getting some output over there. So at that before that getting the output, what amount of output we have to get, so it can be create some feedback over there. So whatever the difference between output signal and reference input, so this one creating the error signal over there. This one is the error signal over there. So this error signal which can be actuating some signals which is the US. So ultimately Now in this system we have to producing the error signal as an input, and US is the in the form of output. So ultimately how it can be transfer function can be right. So transfer function, this one is my transfer function. So we can see that output over input, this one is my transfer function, US divided by ES is equal to KP. So from these the equations we can draw the block diagram. Now see how it can be block diagram can be drawn. So ultimately we have to draw this one first. We have to know about this one is my input error signal and this one is my actuating signal, which is the output. Now this one is the actuating signal, which is the provide the some transfer function. Now in that case is we have to provide the one block, so we can getting the some output over there in the form of CS. This output signal which can be given the some feedback over there. So this feedback, from this feedback which can be we are providing the some summing point over there. So whatever the reference input RS and what is the output we have to getting by means of feedback. So we have to create the difference from reference signal and output. So it create the error. This error signal which can be provided in the this block. So what will happen, this error we can modify by means of this controller. So we have to generate the actuating signal by means of this controller. So what will happen, it can be reducing the error up to the 0. Like we are taking the one process and later on we have to discuss, but up till now we can see the block diagram over there, so easily understand what is the P controller can be worked. So ultimately what will happen in a whole diagram, we have to provide the reference signals and then after it supplied over there, and what will amount we have to get in the output. If we have to just take the one example, if we have to producing that this one is my process, whole process, in which we have to wanted to 50% output, 50% output after this process. But whenever some amount of the reference signal we have to provide, so raw material we have to provide over there, so we can producing the 50% amount, but ultimately we are not getting the achieving the 50%, but we are just achieving the 45%. So what will happen, it can be giving the feedback, we can generating the only 45%, but we have to standardize this one 50% we have to achieve. So 5% which is the our difference, 5% which is the difference, which is the error, So what will happen, we have to reducing the this one a 5%, which is the we can adding in the this one reference signal, which can be increasing the this one 5%. So what will happen, it can be 5% difference which can be increasing the errors actuating signal. So what amount, 5% rise of the actuating signals. So what will happen, row signal which is the increase the amount of raw material, so we can reducing the this error as amount of 0. So ultimately we are getting the 50%. So that kind of work can be done by the P controller. So this one is the process when we are using the proportional controller. So proportionally we have to reducing the error. Thank you for watching.